Okay, in our last example, we wrote down the domain of this function represented by this V-shaped graph. And we discovered that the domain of this function is all real numbers. So in this example, we want to write down the range of the same function. So this is about our third example of writing down the range of a function represented by a graph. So you probably have a pretty good idea of how we're going to proceed from this point. What we want to do here is sort of look at the extent of the graph along the y-axis and to discover the minimum output value from this function, and then also the maximum output value from this function, and then that will give us an idea of what the correct range set is for this function. So if you look at the graph here, you can pretty quickly tell that the smallest output value here from this function is going to be 0. That corresponds to an input of 2. So the input of 2 has a matching output of 0. And since the graph doesn't extend below the x-axis, that means that our minimum output value is 0. So I think it's safe to assume that the range begins at 0. Now, if you look at sort of the top of the graph here, it's easy to assume that the maximum output value is 7. Because the last point on the graph that we see plotted on the right here has a y-coordinate of 7. And the last point that we see plotted on the graph here on the left also has a y-coordinate of 7. So it would appear that the maximum output value is 7. And so you might mistakenly write down that the domain, the range of this function is numbers from 0 to 7. But like in our last example, you have to pay attention to how the graph is actually drawn. Because this graph is not explicitly terminated on either the right or the left with an open or closed dot, what that tells us is that in fact we have to assume that the graph is going to continue indefinitely on both the right and the left. And if that's the case, which has to be our assumption, then in fact notice that the extent of the graph along the y-axis extends all the way up to positive infinity on the y-axis on both the right-hand side and the left-hand side of the graph. So that means that our output values also go up all the way to positive infinity. So in fact, instead of having a range here of from just 0 to 7, we actually have a range of output values from 0 up to positive infinity. That is, any number between 0 and positive infinity will be an output value for this function, and so it would be included in the range. You can write out this set of numbers from 0 to positive infinity in words. That's just the set of non-negative real numbers. An easy way to write down the range is just to say that it's the non-negative real numbers, and that's a perfectly valid way of writing down the range. You can also write the range down now as an inequality because the set of non-negative real numbers, those are going to be the numbers that are greater than or equal to 0. So you can also express the range as the set of all values y that are greater than or equal to 0. So you can also write the range down as an inequality as well.